Please title these notes Derivatives 8 Notes, Prerequisite Evaluating, and write today's date. By the end of this lesson, you should be able to evaluate trigonometric, exponential, and logarithmic functions. There are a couple things you just need to have memorized. Very important to do so right now because these like to come and bite you on complicated calculus problems, and you don't want to be worrying about these, and you got bigger things to learn. So know these, know them cold, sleep with them under your pillow. First thing, quadrant angles. 0 angle, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. You absolutely must know what the coordinates are on the unit circle at each of those. So 1, 0, 0, 1, -1, 0, 0, -1. You can always remember these. This is just like if you were going to read that point on the normal sort of XY coordinate grid. Go over 1, up 0, 1, 0. Make sure you know those. Likewise, you should be able to identify the negative quadrant angles. 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. There are also a couple of special triangles that you absolutely must know. They are the 30, 60, 90, except in radians. So this is pi over 3. This is pi over 6. Pi over 6 is in a smaller angle, so it's 1, 2, root 3. Remember the root 3 and the pi over 3 are across from each other. The other one is the 45, 45, 90, except in radians. That's pi over 4, pi over 4, 1, 1, 1, 1, because these are both the same angle, and square root of 2. Make sure you are incredibly solid on those. The other things to memorize, and really if you memorize these, you should be good to go, but they're absolutely a prerequisite for doing these problems correctly. Sine of an angle in a triangle is opposite over hypotenuse. You can fill these in ahead of me, I betcha. Cosine of theta, adjacent over hypotenuse. Tangent of theta, opposite over adjacent. And then there are 3 other ones that we first learned last year. Cosecant of theta is 1 over the sine. Secant of theta is 1 over cosine. And cotangent theta is 1 over the tangent. Notice the C goes with the S, the C goes with the S, and tangent and cotangent both have the same word in them. There are 3 other definitions that we'll use for sine, cosine, and tangent. Remember, if we have a unit circle, the unit circle means that the radius is 1. And if we just have some point x comma y, then if we draw our little right triangle, the opposite side of this angle is y, the adjacent side is x. So that means that sine, which is opposite over hypotenuse, is just y over 1, or y. Cosine is adjacent over hypotenuse, x over 1, or x. And tangent is opposite over adjacent, or y, over x. Whenever we go to do problems using these, we're always going to do the exact same procedure. We're going to sketch the angle, we're going to draw the triangle or mark the point. and then we're going to use our definition. So let's give that a shot. The first problem is going to be to find the sine of pi. And we said the first thing we're going to do is sketch our angle. So right here, let's go up. Remember, this is where you need to have these memorized. Pi, right there. So this is the angle in question, that's pi. And then we're going to either draw a triangle down to the x-axis, or we're going to mark the point that we're using. We can't draw a triangle down to the x-axis because we're already on the x-axis, so we're just going to mark the point on the unit circle. -1 to the left, 0 up. Now I'm going to use the definitions. Does it make most sense to use sine as opposite over hypotenuse, or sine is equal to y? Well, we don't have a triangle to have opposite over hypotenuse with. So that means we're going to need to use the y definition for sine. So I'm just going to mark that in. Sine is y. So if I come over here and say, what's the y coordinate of pi? Well, that's 0. And I'm done. We can think of this kind of as a triangle that has a hypotenuse of 1, an adjacent side of -1, and sort of an opposite side of 0, in which case we would have 0 over 1. Same thing. Next, let's try to find the cosecant of pi over 2. This is going to look kind of funny. The thing that you have to remember is that the cosecant is 1 over the sine of whatever the angle is. So this is the same thing as 1 over sine of pi over 2. And sine of pi over 2 we're going to find in a very similar way to what we did up here. We sketch our angle, pi over 2 is right up there. We mark our point, so that's 0, 1. And then we say sine is the y value, and the reason again that we're using the y value is because if we just draw a line down to the x-axis, it doesn't form a triangle. And so we can see that the sine, the y coordinate is 1, so our cosecant is 1 over 1, or 1. For our next one, let's find the secant of -3 pi over 2. Secant, we need to remember 1 over cosine of -3 pi over 2. So we'll sketch that. We're going around this way, so -3 pi over 2 is right up there. Same coordinates we were just working with. Cosine is our x coordinate, so x is 0, 1 over 0. Remember, anything divided by 0 is undefined, not 0. Okay, let's move on to the ones that work with triangles. So let's find the cosine of 2 pi over 3. And we'll draw our angle first. This is 0, pi over 2 pi, 3 pi over 2, 2 pi. First thing we have to do is figure out where that 2 pi over 3 goes. There are a couple of ways to think about this. One is that you can think of this as 3 pi over 3 and just say where is 2 pi over 3 in relation to that. 3 pi over 3 is a little bit smaller than that, so the angle would be going right here. Another way to think about it is to convert all of these to having a common denominator. So if we were going to do that, we would say that 2 pi over 3 times 2 over 2 is 4 pi over 6. Multiply these out. Gives us 3 pi over 6 and 6 pi over 6, and 4 pi over 6 would fall right in here. What we're going to do now is create a triangle so we can use our special triangles. Remember, we're always going to draw it down to the x axis. We can figure out what triangle goes in here by simply using logic. If this is 3 pi over 3, we've gone 1, 2 pi over 3, and there's one more pi over 3 to go. The other thing we can do is just use our trick of covering up the number there. That's going to give us what the angle right here. It's called our reference angle. So here we've got pi over 3. We know from our special triangles that across from pi over 3 is root 3. And then the other side is 1. The hypotenuse is 2. So because we have a triangle, it makes sense to use the adjacent over hypotenuse definition of cosine. So to get that, we would just say the adjacent is 1, the hypotenuse is 2. However, there is one very important thing that isn't in here that you should make sure to always have. This one is going in the negative direction, so that has to be a -1. This should be a -1 as well. Very easy to forget. For our last example, let's find the cotangent of -3 pi over 4. Remember, cotangent is the same as 1 over tangent. So we're going to do 1 over the tangent of -3 pi over 4. Sketch -3 pi over 4. We're going in the negative direction, so this is 0, pi over 2, negative pi, -3 pi over 2, -2 pi. If we get common denominators, this is going to be -2 pi over 4, -4 pi over 4, and -3 pi over 4 falls right in between. Again, we draw our reference angle. The reference angle is going to be pi over 4. That means that the sides are 1, 1, and square root of 2. However, this is in the negative direction, -1. This is going down, -1. Tangent, because we have a triangle, it makes sense to use the y over x definition of tangent. So this is 1 over -1 over -1, or 1 over 1. Let's do a couple more examples with the triangles. How about sine of pi over 6? So first we go ahead and sketch it. We know that pi over 6, that is going to be the small part of the pi over 6, pi over 3 triangle. So we know that it's in the first quadrant. It's less than a 90-degree angle. However, if you don't remember that, you can also just get common denominators. This is going to be 3 pi over 6, and 1 pi over 6 is definitely less than that. It's right there. So let's put that pi over 6 right there. This is a 1, 2 square root of 3 triangle. All of these are positive x direction, positive y direction. And so at this point, all we can do is look at sine. We know that sine is opposite over hypotenuse. So the opposite side, that's going to be 1. The hypotenuse is 2. So our answer is 1/2. We can do a similar thing for the cosecant of pi over 4. Let's work again with one of those reciprocal functions. We know that this is the same thing as 1 over the sine of pi over 4. And so once again we can sketch that. The quadrant angle is 2 pi over 4, and 1 pi over 4 is less than that. So that means we're back here in the first quadrant again. Our triangle is 1, 1, square root of 2. We know that, again, sine is going to be opposite over hypotenuse. So that's 1 divided by, opposite is 1, hypotenuse is root 2. And we know that dividing by a fraction is the same as multiplying by the reciprocal. So it's the same as 1 times the square root of 2 over 1, or simply square root of 2. In addition to being able to evaluate trigonometric functions, you should also be able to evaluate logarithmic and exponential functions at particular values. Here are a couple things to remember. First, anything to the 0 power equals 1 as long as the base is not equal to 0. And even if the base is equal to 0, anything to the first power just equals itself. On the logarithm side, log base a of 1 equals 0. Log base a of 0 is undefined. And log base a of a negative number is undefined. Let's look at some examples of those. First of all, over on the exponential function side, so let's say we have e to the 0. This actually shows up a lot. E is just a number. It's about 2.78. So e to the 0 power is simply 1. That's all. Similarly, if we had 3 to the 0, that would still be 1. If we had 5 to the first power, that would be 5, using that rule right there. If we had e to the first power, that could also be written as e. On the logarithm side, let's see where some of these come from. So we know, for example, that e to the 0 power equals 1. So if e to the 0 power equals 1, then we can undo this e to the power of by taking the natural log, that's log base e, of both sides. So that means ln e to the 0 equals ln 1. These undo each other. So 0 equals the natural log of 1. That's where this right here comes from. So now that we know that, we can just use it as a shortcut. So if I said, okay, what's log base 3 of 1? Just use those rules. 0. On the other hand, let's say that we were in a situation we were saying find log base 3 of 0 instead. Let's say that just means is x. Well, we might not know that off the top of our head, but where this rule comes from is that we can undo this log base 3 by doing 3 to the power of. So log base 3 of 0 on both sides. These undo each other. Zero equals 3 to the x. The thing is that there's nothing that we can put in for x here that will make this be true. If we put in, say, 10, 3 to the 10th power is positive. 0, 3 to the 0 power is 1. Negative number, 3 to the negative first power is 1 over 3. It's still a positive number, it's just a fraction. So this is not possible. No number for x will make 3x equal 0. And so that means that we can just make a shortcut. Find log base 4 of 0. That's undefined. The same logic holds for finding the logarithm of a negative number. Let's say that equals x. Well, we can undo this log base 2 by doing 2 to the power of both sides. But once again, we're left looking for what number can we do 2 to that number and get a negative number? Once again, there's no number. 2 to the 0, that's 1. 2 to the negative 10th, that's going to be a fraction, but it's going to be a positive fraction, not a negative fraction. So this is also not possible. 2 to the x is always positive. So similarly, let's find natural log of negative 3. Can't take the log of a negative number, so this is undefined. This concludes these notes.